I hope my screen is visible to you. Please respond, someone.
Yeah,
Yeah.
visible.
So, very good afternoon to everyone. This is Suraj Vaishnav. I'm a senior application engineer working in India Soft Technologies Private Limited. So, I'm going to present you a witness simulation software, which is basically a discrete event simulation software and can be used for various applications. Like you can say, it's applicable to manufacturing as well as the service industry. So it has a two editions. Like for example, I search here a witness, and you will have a witness horizon, and this is a witness horizon service edition. So basically, you will get elements which are related to service in the service edition. So witness is a, you can say, a first of kind of software like modeling and simulation drag and drop environment type of software which was developed by Lana Group Limited in the UK. It is that kind of a first technology where drag and drop application had been used in the discrete event simulation applications. So this is the total history. I'm not going to explain you that. So from like in 1996, they were developing this software. Okay, so but in 2002, they have launched a very super commercial version in the market. Till that time, they were doing the consultancy on that software, but not a commercial launching of that software was not done. So from 1996, they were doing that work. So it's from the Lander Limited UK, and we are their authorized channel partner for the whole country in the academics in the India region. So only we from last 15 years we are their partner. So we are serving them. We are serving on behalf of them for the witness solution software in the country. So you can see, I'm not going to go in detail of the what which company and how was the functionality and everything. So it's a basically discrete event simulation. As I said, it has elements, and you can see in the right hand side image like part, buffer, machines, and conveyor. Similarly, if you go to the continuous industry, you'll have a continuous element like this, like tanks, pipes, okay, chemicals. So these are the elements. Now you will have a various element, like if you go to the service industry, for example, or hospital management or something, you can say service industry, as I say, then you will have elements like this. You can see service pack. In the service pack, you will have a bench, desk, chairs, okay, trolleys, beds, okay, reception desk, laptops. These are the elements, a workstation, you can say. So basically, we have a discrete as well as a continuous element like this in the chemical industry if you want to use that. So how the approach we should have in the software. So collection of the appropriate data, structure the model, build the model, run the model, then generate the report. If you want to do some what if analysis, then do that, and then do experimentation optimization even if that requires. So we have a optimization also, that also I will show you. So we have a various algorithm for the optimization purpose, as I said, like minimum max, hill climb, random process, okay, Six Sigma. So these are the various algorithm we have for the optimization purpose. What we can see teach like in the production area, CMFMS area, bottlenecks area, bottlenecks like concept we can teach a supply chain management related topics in the witness simulation software very easily. That is also I'm going to show you. I think our focus is supply chain also main focus is supply chain only. I heard from the Sibashis. And I will not go in the much more detail. Okay, like these are the commercial user, worldwide user. Okay, Ford Motors, Nissan, Air France for the baggage handling system. Okay, as well as some case studies on papers on the supply chain. Also, I'll show you. These are the industry where it is used, like manufacturing, where it's applicable basically. And we also have a 2D to 3D simulation, and then we have that if you have that 3D glasses or virtual reality technology, so you can connect that to the computer and it can be seen like this. So you can do a logic coding in that software also. Like it supports various languages, C++, C sharp, visual basic, then Java, Python, JavaScript. So you can do that logic building if you want to do various types of example we can do that. I'll explain you as we go ahead. So you can see this is the some of the example. Like witness saves Air France 2 million euros on his baggage handling system. So they simulate a baggage handling management in the witness simulation software, how to manage that according to the crowds, and how many belt and should be operated, and how much time, everything has been simulated. So this is manufacturing related. This was a service manufacturing. You can see a Ford engine assembly lines related. Then various user, I'll not go into detail. Your BIT Mesra campus is also a user of witness simulation software, as well as a bit Pilani also. They are in the talk, basically because of the COVID, their purchase process has stopped. But in the Jan, after December or Jan, they are going to have that. So they already budgeted that. So I'll just open a witness simulation. This is a manufacturing edition. Okay. Then I'll move to the service edition. You have a various elements, parts, buffers, machines, labors, for example. Then you have a transportation purpose, vehicles, tracks, okay, overhead carriers, you can see gantry, and all those elements are also possible. Okay, conveyor, parts. Then you have a, for the continuous process, as I see it, like liquid, tank, processor, pipe. Then you have a various, in if you want to work in the manufacturing area, you'll have a various types of machine elements. If you want to go in the service area, you will have a various type of service element, as I already told you. Like witness has a drag and drop facility, drag drop. So as I say, I'm just showing you how to use a witness. Then we'll move to some ready-made example which are available with me. So this is a manufacturing related example I'm explaining you. So I will taken a part. Then go to the, for example, transportation area. I say conveyor. Why conveyor? The part will go to the machine. Okay. I also want to add one more conveyor, and then it will go to the next machine, and then it's okay. Okay, so that's is how much I wanted to add. I'll give your name of turning, one turning machine, for example. I can give milling. Okay, so as per your convenience, you can give the name as per the problem statement what you have. Then the part goes to the conveyor, conveyor to turning, turning to conveyor, then milling. Okay, then part goes out of the system. For example, I select track connect, yes, and I say okay. So basically here you can see these are the rule, inputs rule and outputs rule. For example, conveyor will send output to the turning, so I have to select the conveyor. Here is you have to select the output. Output goes where? Turning. I say okay. From turning, sorry, from turning, output goes to the conveyor. Okay, conveyor output goes to the milling. Okay, so after milling there is no element, so I ship that element, ship. I say okay. So I have to do output only, but output will be in the terms of a shipping. So now I, for example, I want to add a labor for this machine. The labor will be required for the operation. For this machine also labor will be required. So I have to select this machine. Here is the labor, a labor for this operation. Save close. Milling, labor rule. Which labor? I have to select that and close. Okay. So this is how simply drag and drop connect elements. Very easily we can build a model. So from whichever area we can build a model. I'll show you some of the ready-made example as we go ahead. Now I have to put the statistics related to these elements. So for example, any quantity of a product is coming to the system. So what is the interval time after 2 minutes is coming, or you want to use a distributions for this interval time. So you have a various distribution here. Binomial distribution, log, normal, triangular, okay, uniform. So for example, I select a uniform, I can add like this, insert with distribution wizard. So minimum how much is the uniform, maximum what is the uniform distribution value. So I select, for example, 0 to 2, and I say okay. So it comes as a uniform 0 to 2 directly. So I'm not just taking, so for example, you want to see a negative exponential, and I say insert with the distribution result. So it will ask for the mean for that negative exponential. For example, if we go for the triangular distribution, insert with the wizard, it will say min, mode, and maximum is what for the triangular distribution. So I'm not taking any distribution right now. After 5 minutes, the part will come to the system. Okay, you can also add a costing for that, each and every element. Okay, so for that part, what is the cost, fixed cost per unit, per part creation cost, what which revenue you will get. So I'm not going to add anything right now, otherwise it will be get complicated. Then I say, for example, these parts are coming to the system, but I want to say import the data from the Excel sheets. So like for example, in the various industry, the part arrival data will be in the Excel format. So import from Excel or any other software like a mini turbo, you can say. So that can also be imported in the Excel or any other statistical software. I say active and I say okay 5. Okay, so just now I'm taking a 5. For example, I just changing here a 3D visuality graph. Have you ever used discrete event simulation software before this, sir? Anyone? Anyone has used?
No, no.
Okay, no issue, no problem. So this is how we got it in the system. Row 5 I have given here. I go to the conveyor and I can put what is the index time. Basically, I hope you know the indexing. I think you're all of from production background area. So the time required for movement of that part from one position to another position on the conveyor, that's called indexing. Then after that, a length in a parts, how much parts it can store at a time. Even 10 is not required. I can even say 5 parts it can have. The length of that conveyor 5 parts capacity. You can add a breakdown to this conveyor also, a breakdown maintenance you want to do. So that can also be possible. Costing per unit use of that conveyor can also be added. So in the final we'll be able to get the revenue generation if we add costing to each and every elements. Then I go to the turning. Similarly to that, after 5 minutes parts is coming to the system. For example, I'm putting a simple cycle time. The part will be get work for the 5 minutes. Okay, that that the product will be get work for 5 minutes. I can add a setup time, I can add a breakdown time. Okay, so I'll not go in much detail, even add a breakdown as I said. Similarly to the past statistics 5 and here 0.5. Okay, then again in the milling, similar, everything is similar, I'm keeping it as a 5. So same like a previous machine only, we have added all the elements and I start the simulation. For example, you will able to see after 5 seconds each and every the parts are coming to the system. So this is how the simulation is going on. As soon as the parts comes to the workstation, the labor goes and he works. Here you can see, you will see there's some yellow and green signals. So yellow means it's idle basically. Green means it's working. So continuously part is there and it's working for 5 minutes. Then it's go ahead. As I increase the speed of the simulation, here's the options of increasing the speed of the simulation. And if I stop this, I select the statistics. So you have how many parts entered in the system, how many parts shipped. Okay, what is the average work in a progress basically right now, how many parts in the work in a progress area, what is the average time required for each and every part, what is the chart statistics for that each and every parts. Okay, so this is also there. You can export the data to minitab also, a print you want to do, you can do that. The charts you can see similar to the statistics like this. If you go to the detail conveyor statistics, which conveyor was busy, what like we get each and every machine level utilizations. So what if you build a model like this, what is the utilizations? Similarly, turning and milling level machine, idle was, busy was, how much time, number of operation completed by this machine, their chart statistics are also we have. Then you have a labor related to that. So labor related statistics, which labor is working for how much time, so every statistics related to that, it is available there. Similarly to this, we can convert that model from 2D view to the 3D. For example, I go, I select all the elements, I'll keep those in the linear format, so we will get a good view. And I convert that model. You can see a quick 3D goggle, and we will convert that model from a 2D view to the 3D view. So I think it required an NVIDIA graphic card, a good graphic card. Basically, a 2 GB graphic will be good. Otherwise, you will not able to get a good 3D view. Sometimes this image will turn into black and white only. So if you don't have a good graphic card, this is a simple just basically, so for the presentation point of view, if you are doing a presentation somewhere, so for that purpose 3D, or those people who don't know the simulation, basically they don't have an idea of simulation, so for them purpose the 3D has been added, so easily or better way they can understand. So that is why the objective of addition of the 3D was that. So this was a 3D in the simulation software. Now, for example, if you go here and I click a sample model, a various level of sample models I have with me. For example, this was a manufacturing related. For example, I open now a service related model, which is in the clinic area. So here you can see a clinic related model. For example, here the connection, you can see there's a lot of complicated connection we are done here. So parts are coming on trans. So have we can hide that connection here. The element flow we can hide. Here you can see for example, a reception desk. The here from the reception desk, now there is no simple rule like I say output rule. You can see percent goes to Q assessment 50, Q treatment 50. So what that means? So basically from the reception desk, whatever the number of people comes to the reception desk, 50% go for the assessment purpose, 50% goes for the treatment purpose. So assessment is basically a primary checkup, and treatment somebody might have taken appointments, and those people like 50% goes for the direct treatment. They don't require assessment. And there is a set of a doctor which is service, and we have a three beds for this, and we have a three beds for the treatment. So this is how we are able to, we have done the model building here. Similarly, for after doing assessment, somebody might require a treatment. So you can see here is in the output rule, you can see after Q treatment goes to the 60, served are 40. Okay, so whatever the assessment is done, served 40% go out of the system, but 60% goes to the treatment again. You can see here is a double arrow from these beds. These are the beds, you can say service stations for the patients. Okay, so similarly, I start the simulation in the 2D view, you're able to see. As soon as the patient comes, doctor attains that. So for getting those data managed properly, how much bed you can require, how much which area require how much bed, how many doctors or nurses you can require for that decision making, this type of simulation software use. Before going to the 3D simulation, I just want to show you, let me show you one example, just a second. um, One case study which we got from the industry right now. I have to work for on that project for some time, so let it open. Basically it is just a second, ATPL, ATPL. Okay, just a second. It's a commercial case study, and yeah, sorry. So this was agreement, final agreement, agreement. Just a second, sir. I just want to show how, what type of data and up to what time this type of work goes, to what level, basically. Yes, this is the data. This is like you can see, Manoj Chikaltankar is the head manufacturing engineering India of Allegro Technologies Private Limited. They got the project on the witness from the Ford, basically Ford, which is in the Europe, and they got a project on the witness, and they were having a, they want to do a simulator virtual. This is in the language, basically French language, but I'll go in the details. Here you can see this is the shop floor, this is a plant layout, and this is basically a robotic plant. They want to build a plant, they want to do a virtual simulation. This is the in the detail layout model of simulation. So various robots are there in the system, and that simulation model, we have to do a simulation in the witness simulation software. The compulsory the mention that we want a case study from the witness only. So these are the data which they have shared. They have to start work in that area. Similarly, you can see their specifications, the Ford specifications, the specifications. Just a second. Yeah, body shop simulation project. Everything they are specified. Details, what type of geometry, how, what is the drawing of that simulation, their images and everything has been mentioned with us. Their CAD drawing also they have shown, and they want results via witness only. So this is how witness has been used and is being used for various simulation exercise. Yeah, these are the various specification. I will not go in that much detail right now, but this is the Ford project from the Ford we got right now. So this is a, I was there in the service, I convert that into that model from 2D view to 3D, so you'll able to see the 3D environment, so better view you'll able to get. This is a service example. Again, this is a service example. Okay, so now I'll move to the one more next example, which is you can say a supply chain model in the dairy. You can say dairy area. Just a second. Discrete and continuous. Okay, so here is the example of the dairy plant. Basically, here we have shown to taking a milk from this area and doing the processing on that milk basically. Okay, so the processing is done, the separation of milk and the fat, you can say cream, is taken here. After that it has been sent to the containers, and then carrots are done and dispatched in this area. So this requires not only a discrete elements, it required a various element which are related to the for managing this supply chain. It requires continuous elements also. As I already shown you, the continuous element like the processor tank, then there are some pipes. Okay, so their fluid rates and all those things has been specified. Okay, so there's a separation tank. Okay, then after that there is a pipes again, then there is a milk storage, then there is a cream storage, and it is sent to the cream is sent to the different sections, then milk is sent to the different sections, and then through buffers the carrots are dispatched in this area. So I start the simulation. I think some at 9 o'clock or some timing it will simulation will start in the morning area, morning time. Yeah, okay. So this is our simulations. Unloading the milk. I'm running at a very faster rate. If I go explaining each and everything, it will take, require too much of time. So this is how a complete model we can virtually simulate in the environment, and we can get the decision before doing a decision before implementing any simulation model. So right now our office our general manager who is here with us, Mr. Sunil Chore, he's having a work. He is doing his PhD subject is basically supply chain management in the agriculture industry. So basically milk area, as well as he want to do some fruits related supply chain management work. So that subject he had chosen, and his project will be basically in the witness simulation software only. And he deliberately chose that area, so he want to see the simulations and get the results in the witness simulation software. I'll show you the what kind of study or work he wanted to do. Here you can see this is one of the example, simulation of agriculture product supply chains based on the witness simulation software. So basically this is the one of the paper which has been done, work is done by some Chinese academicians. Okay, so I can share this examples and papers. Okay, so agriculture product supply chain model. So you will have agriculture products, then raw materials, then you will have processing enterprises, sales enterprises, agriculture consumers, then governments. So there's a linkage between all these elements. So they try to simulate that their conditions, their rules has been mentioned here. He has done that work. So buffers, like we have mentioned what element represent what. So for example, C1 C2 represent the inventory for that respective area, like service area inventory, processing area inventory, machine, this is the agriculture products, machine A2 agriculture products, logistics service enterprises. Okay, so everything he has mentioned. So this is the virtual analysis. This work has been done in the older version of the witness. Okay, so that's why you'll find some color difference. So this is the example, like agriculture produces, these are the various service stations. Then these are the conveyor he has taken in the same of a path of traveling basically. So that the traveling you can mention in that area. So whatever the traveling path you can mention, like they have built a very simple model, we can make it very fancy. You can add a vehicle here in this environment, their graphics and can also be added. So that can also be done here, and you can show that as actual vehicle movements and all those things. Then it goes here. Then next is the next sections, agriculture product processing enterprises, then agricultural product processing enterprises, as I said. their statistics and results he has mentioned here. Improving in the which area, okay? So improving where improvements are required. So these are the various work they have done in that supply chain of that area. This milk example has been done by me. Now one more example I wanted to show, one simple supply chain engineering. Just a second. Yeah, this is one of the example. So it's a simple one example. Here you can see there's a customer and then there's a retailer. It's a pull based supply chain basically. Customer has a demand, certain kind of demands, daily 1 to 8 parts required. So that is the demand has been customer is generating basically. Okay, so according to that, the retailer has to fulfill that demand, and it should have a minimum quantity which can fulfill the demand of the customer. So there is a retailer. As soon as the retailer it also supplies in the form of a 1 to 8. Okay, so basically it also supply in the form of a batch of 1 to 8 as customer requires in the batch of 1 to 8. It also supply in that format. And here we have given some of the rules that uh, it will what it will happen. For example, after certain amount of a time, if the value of this decreases, like for example, if this value decreases below 50, I have given the rule in the inside. I'll not go in the detail of that, because you can see there is a connections. You will not able to generate what is connected where. Okay, so I'll not explain you each and everything, but I'll give you the idea, basically just idea. I'll remove the rules window. Now basically, as soon as retailers quantity of products goes below 50, he has to generate order generator will send orders to the warehouse basically, and the manufacturer will send to the warehouse. Okay, picking will be done, and as soon as the orders are picked, then it via delivery station it has delivered to the retailer. So I start the simulation of very fast amount. Just a second, I have to go at very slower slide. I'll reduce the slider, so very slower mode. So for example, now the value is decreased below 50. For example, I had told, as soon as the value has been decreased, it will supply it. As soon as the value is decreased, order generated for the 50 parts. Manufacturer has a capacity to generate 88 parts daily, so he supply 88 parts daily to the warehouse. Okay, so order has been generated. As soon as the order has been generated, he gives the orders to the orders to pick area. So warehouse area he sent the order basically. So from there we want to order. As soon as the warehouse receives the order, whatever the inventory warehouse has, he sends to the picking area, then picking area to the goods for delivery area, and in the delivery area. So basically delivery, so delivery supply, as soon as delivery get 5 to 30 parts between in the batch of that, for that day how many parts he is able to get, 5 to 30, he supplies to the retailer as soon as it goes. So basically his work, the delivery person's work is, this should not go to the zero. Before going to the zero, he should supply to the retailer. So you can see, as soon as the value comes to the zero, the delivery person will supply to them. And in the meantime, the retailer generates the orders as per his requirement each and every time. So now retailer is reached to zero. Now it has to supply that. Yeah. So the delivery person work is to supply, and he is supplying whatever the element amount he was having. So this is how a linkage is working in that area. Some example of a value stream mapping, like this was not only that. On the desktop, I have, yes. So value stream mapping example, like there's a various scans. The timings are also different. The manufacturing of can we are doing in this area basically. So the dispensing, blending, filling, packaging, each and every operation has been added. and each and every can might have a different values, different quantities has to be manufactured. Okay, their size, their everything in charts. You can get pie chart or real time histograms, various types of graphs we have in the witness. Okay, so you'll get a data in the various different charts. So detailed pie chart, various options of having a graphs we also. As soon as, like for example, if I go here, I select the results. As I show here in the chart format, you will get the option of doing that chart designer. So which type of chart you want, that is available there. So this type of various charts are available. For example, let me show you the chart again. Uh, just a second. Chart, right click, chart designer. So line chart, plot chart, combination, pie chart, XY chart, polar chart, histogram chart, radar chart, okay, contour chart. So these are the various type of charts we have very easily available in the witness. So depending on your requirement, what you want, those can be taken here. So a witness papers and case study, what we have, what I have, let me show you that. Yes, witness papers various. You can see like shop floor, supply chain related. Here is one performance measure of supply chain flexibility using witness. It's done by these guys. You can see they are from India only. Okay, must NIT Trichy, Durg, Durg, CSIT Durg. So these are the professors. They have done that work. But so their P93 is basically very older version of simulation software. Very older. It's like 10-year backs they got. Here you can see some of the screenshot from the witness software. This is an older version. You can see. You will able to see like in Windows XP or 7 that was opened. So that was now it is matured and very good graphics has been you can see in the latest version. So these are the complication level of their model was there. So trucks and all those things they had used here. You can see the elements and their calculations related to various work, various samples they have tested. I'll share that all those example with you required. This is a hospitality management, hospital pharmacy. The health pharmacy he wanted they wanted to simulate. So their statistics and all those data collection they do, and then they build the model in the witness. This is a conceptual model in the witness. Okay, and this is in the actual environment of the simulation environment. Reception, pharmacist, cashiers. They have used a service edition basically. Service edition in the service edition, they have used this labor and elements and all the work. And they have also specified witness solutions are very much optimal. This is a PSG college. I hope you know that Jay Chitra and Prasad sir. They are also witness solution software user. You can see like in 2010 they have done work from that much of your and uh, they take the simulation software whenever they want to upgrade. In future they upgrade that. Otherwise they want to use the same version they can use because the license is a perpetual for that purpose. So this is the example, and they have built that in the witness. Their statistics, they have taken the data to the minitab and they have done various further statistics in that area. This is the traffic controller, exploiting witness simulation for traffic simulation. So the applicability software is very vast. You name the industry, manufacturing or manufacturing or service, In any area it can work. So these are the traffic simulation. In the Europe, like basically UK, they had done the study. This is the simulation model in the witness, the lane and everything which was built in the witness. So basically, it's a validation tool. Before going for the actual implementation, it's a validation tool. Like for example, I show you an example how validation tool, as I said. For example, start model. Just a second. I'll give you some example. For example, here is the. I'll explain you the things. The part which is there, it goes to the production purpose. Then via wash buffer, it goes to the washing. Okay, and via weighing buffer, it goes to the weighing. Basically, production is done here. After production, we want to wash the product. So washing is done. After washing is done, we want to count that value, counting process of that weighing process, basically weight counting process. Via conveyor, it goes to the packing area. Packing is done. Here is the option of a technician, for example. He is the labor who is going to serve this packing process, his primary work. But now on the wash machine, we have added a breakdown. For example, if you have a lathe machine or a milling, turning, any machine, the tool has certain amount of a life. It comes with a life. So you can incorporate that life, the tool life, and you can see like after like you require that to tool failure and tool repairing time or tool changing time you can add here. For example, this failure occurs of between 100 to 300 minutes. Between each and every 100 to 300 minutes, it's going to fail. Okay, and triangular distribution way it's repairing. So for a triangular distribution way, in the sense I had taken here, first 30-minute first breakdown occurs, it will require 30. Next breakdown occurs, it will require again 30. As soon as they go ahead, again the for the next breakdown, it will require 90 minutes. So repairing time, as I said, I was saying 30 minutes, 60 minutes, 90 minutes. So repairing time increases step by step and daily. As soon as the breakdown pattern increases much more higher. Okay. So this is how, and the breakdown will occur at each and every point. Okay. Here you can see 100 to 300 minutes breakdown will occur at each and every time. So as I start the simulation, you just observe each and everything. It's a very interesting for the decision making. This example, this is one of the simple and first exercise I generally teach to everyone wherever I give the training. So this simple and very important example for understanding purpose how, what, why witness is used. So you can see here and as soon as the failure occur here, wash machine, you just observe that. I will pause the model, then you'll able to observe that between it at any time in the uniform distribution I have specified 100 to 200 minutes it will fail. Okay, so as soon as it goes.
Sri Santos, have you any model for medical supply chain management and how to
Right now I don't have one pharmacy I had able to show you, but medical related to directly detail related to that I don't have right now. We have to build according to, depend, I'll have to search in the Google. If I found some case study, I'll directly show to you.
Okay, mainly
Okay.
our problem is to analyze the supply chain behavior of essential product during COVID-19 pandemic and
Okay.
identify the critical factor that created disturbance and optimize the parameter that affect the supply chain and generate a best model to smooth flow of essential commodities like medicine and medical equipment. So,
Okay,
how
so
can
that
we
is,
simulate this type of thing in your software and how can we optimize?
yeah, we can do that. It's depending on the data what we have. We can do this area, like for example in the optimization I'll show you one example. Okay.
Okay.
How to optimize, for example, the clinic example which I had taken, I hope you have seen the clinic example.
Yeah.
Okay, so the clinic example which I had taken, I'll go to that clinic again. Okay, just a second. Sample model, sorry.
I think your
Start.
pharmaceutical model are suited our project. If
Yeah, pharmaceutical model.
yeah, yeah.
Definitely. I don't have a ready-made pharmaceutical model because it requires a time to build a model. Each and every time you require a time. Like for example, this one chemist related model, raw material, and these are all generally we are producing what chemist that related models are there. So chemical plant. So basically, this will not be directly linked to your area, but we can do this type of work very in the witness because it has been used in that area, and people are using this for the warehouse management as well as simple supply chain management, simple logistic management. So deep in that area, like for example, this is one of the simple supply chain related example. Here the you can see you can see these are the elements, a truck which is there, okay, and it goes in the waiting. From waiting it goes to the loading area, okay. So their example, it's a very simple example which we just show to the example to show to the customer, like these are the small example we can build, but depending on your problem statement, what data you have, according to that we have to think and we have to build the model. Each and every model is like a case study, big case study. Like if you are saying like uh, modeling that type of supply chain related example, nobody will give you the ready-made example, ready-made solution. We have to work on that depending on the data what we have. As I shown you the agricultural example which was with me, agriculture related, for example this was example related to agriculture. Similarly we have to study, and we have to depending on the data we have to go to the a pharmaceutical example. We'll have to study that, and we'll
Mm.
have to understand the software first. Then we'll go to the that end, and I'll help them for the training purpose, for the information purpose. What are the things we can do? What are the changes we can do? What are the elements we can add? This is one of the example related to the agriculture products. Similarly, we can build for the essential commodity. You were saying a pharmacy related example that can also be incorporated in the witness, and no software will give you the ready-made answer. You will have to work on that, and it is very much possible in the witness.
Okay.
That is what I wanted to say.
And how we optimize the various parameters in supply chain?
Yeah, like for example, I was opening an example, a supply chain related example. For example, you have a buffer, or you have a timings related example. Some timings you want to optimize, some quantity you have to optimize, some resources you have to optimize. Similarly here I have a experimentation related example. Yes, just a second. Models, for example, simple clinic with objective, a simple clinic. Similarly the clinic example we had seen, sir, this is the clinic example which is here. For example, now here in the clinic example, what can be our objective? Our objective can be here, this is to reduce the time required by the patient in the whole system. Like for example, in the supply chain also we can have the time, like to reduce the time required for a movement of that product from one position to the another position, from one location to another location. So same analogy you just keep in your mind. Okay, for example, here the our area aim is to send that patient from this whole hospital service area out of the system in the very much lesser timing. The same clinic example we had seen, na, the doctors and actor assessment area and treatment area, same, everything is same. Okay, now for example, you just measure here what is the quantity. The assessment bed 3 quantity, treatment bed 3 quantity, nurse area 4 quantity. Okay, our objective, as I said, our objective is to return of time for the patient is our objective. Okay, so it has to be minimized. Okay, that is the objective, is to minimize that timing. Nurse 4, just observe, 3 beds, treatment and assessment. Here is the option of a simple experimenter, or you can say advanced experimenter. Now that experimenter value I will select the optimization value, simple clinic. So what is the scenarios? We can generate a scenarios. What can be the best optimum resources I should have to get that minimum time? Okay, our objective, as I said, here objective, as I said, it's a minimum. Okay, I have specified everything is readily model I have built already, because it requires time to build model. So everything is built readily, and I'll just explain to you. Our objective is to minimize is what, to the time. And our constraints are also there. The assessment bed and treatment bed maximum quantity should be 6. Okay, total quantity of the assessment and treatment should be 6. Okay, so that is the our main area. Okay, our objective is assessment and treatment bed maximum quantity should be 6. So I go for the simulation. What is the simulation? Basically, the software will do, like, it will change the quantity of the resources of RERs from 1 to 5. It will change the resource quantity of a beds from 1 to 5. It will change the treatment beds quantity 1 to 5. It will do permutations and combinations of the various calculations, like as I said. So simulation is started, and if you go into results, it will take some time. Nurse quantity 1, assessment bed quantity 1, treatment bed quantity 1. It will do calculations for the various quantities. Okay, so you can see, now you don't have to build a 10 different models for building any feasible solution. You can build a single model. According to that single model, you can specify, the values. Okay, the constraints you can specify, and then you can specify the different type of values, and in that values, the software will calculate various optimum solution. Now here it has calculated, for example, if we keep nurse quantity 5, assessment bed quantity 1, treatment bed quantity 3, the patient will require a 68 minute. And now I click on objective. It is saying a 27-minute will be required. If you keep 27-minute in the minimum time, in the 27-minute we can send patient out of the system. If you have the resources of a nurse quantity 5, assessment bed quantity 2, and treatment bed quantity 4. So this is the one of the results we got in that area. So similarly, what you can do here, instead of this 3, you can say, here you can have a 2, and then here you can have a 4, as per our problem statement which was there. And then you will able to see the effect on the results. So this is how we can able to optimize that very easy way, using a witness simulation software. And which algorithm we had used, I forgot to tell you that algorithm. Let me open that algorithm again. So the algorithm which we had used, a combination of all. We have what? Random solution, mid min max, hill climb, simulated annealing, adaptive thermostatical, Six Sigma. So you can use a simulated annealing as well as a combination of all. Simulated annealing is the one of the latest, we can say one of the oldest, and which is used widely basically. So instead of using a lot of algorithm, simulated annealing also you can do. So simulation will start. The software automatically generates the calculation. You can see it is generating at the below. As soon as I go ahead, it is generating. It's stopped now. And as per the objective, we got a 27 minutes. And a maximum, if you keep a nurse quantity 1, assessment bed quantity 2, treatment bed quantity 2, you will get 3000 minutes will be required for that patient to go out of the system. As soon as I click on the my objective option, 27 you will require with these resources. So this is how the decision making becomes very much easier to optimize that. We can specify in that ranges, and we can go for the simulation on optimization. Any doubt, sir, in that area?
No, thank you so much. Anand and Sumanta sir, have you any question to ask?
Yes.
Anand, Sumanta sir.
Is there any example of or case study of this transportation like problems where you can ship things from one warehouse to, like, some central warehouse is there. From there, you take it to the local places, and from where there, it will be delivered to the final customer.
Yeah, I'll show you one example which is with me. Just a second. Models, not in the tutorial. Engineering, warehouse stock or warehouse. Yes. This was a ready-made model with me. Okay, so a lot of automated guided vehicle we have used in this area. So these are the automated guided vehicles working on the tracks, and they have to send us all the elements which are coming from this area. There's a sorting system here from this area. Using this automated guided vehicles, we have to send this to this, basically a retrieval system, primary hub of a retrieval system. And this is built in the witness. It is not built by me, it was readily built available with me, the previous people which were, and from the OEM it directly came. So I haven't built this, not much more detail I don't have in the detail of this model, but it has been, you can see, a production. This is production related. Okay, so automated guided and vehicle related example is there. So various lanes, and the output is sent to in this area and it goes to the retrieval hub. Similarly, one more example I'll show you. Warehouse stock. Oh, no, this will not be very much useful. One office movement I will show, for example. Office movement. Yes, this is one also a service related area. Movement of the elements, people and customers in the office environment, staffs and people. These are the yellow color are the customers, or you can say uh, employee which comes to the office. So these are the various desks. So application procedure and various sections, customer registrations. So this is one of the management type of example which is in the office area. Let me show you if anything else I have to show with you. Shuttle, not for you, it's manufacturing related. Contact horizon, no. Multiplic will not be with you. Chart horizon, no. Ambulance. Yeah, this is basically a call queue management system. So for that purpose, for the ambulance purpose, so it's an example to that. It is also again not built by me, but it is related a service example. I just wanted to show you this type of example has also been built. The office call center can also be that was also built. This is a call center example, similar to that agent based modeling, basically we say, to optimize the calls and all those things is example in that area. Then any other example, that plane schedules. Okay, this is a that airport management system. So scheduling of the all those things and customers coming and they're queuing on their management. It is related to airport management. You can get a real-time graphs for that. In this, you can see it is here. So basically, what this graph explain the details, number of people at the passport counters, basically that is been explained on that graph. Then again, some example. If I have tank, these are a small example. Airfield, And simple, for example, if I wanted to show one assembly horizon, for example, I go here. Like this is a 3D modeling. 3D, you will able to get that. All free from Mega Man. Here you can see. This is some example, basically a gantry model which I wanted to show. This is the 3D view. In the 2D view, it's visible like this. Yes. Any doubt? Any query, sir?
No, it's okay with me.
Yes. Any other thing?
So,
Okay.
Kashif, shall we wrap this up today?
Yes. If you have any questions, please go ahead. Any questions from your end,
No,
Kashif sir?
no. Sumantas, Anand?
Yes, Sumanta sir or who's
Anand.
the Anand sir?
For optimization, there are some preset optimization also we can use, or uh,
You can just a
yes.
second. You can use those directly. It is readily not available with me, but if you have a code for that algorithm, which is written in the language, like as I said, which are the supported by the witness, you can import that in the compatible format for the witness. Let me show you in what compatibility it has. C++, Java, Visual
Hmm.
Basics. Just a second. A Python, for example, if you have that code.
Okay, okay.
Yes, so you can import that in the witness. Like as I said, uh, just a second, just a second. Okay.
Okay.
Support external code library like C++, C Sharp, Java, Python, JavaScripts. Okay. Like most popular language in recent time, which are there, it's available in that environment.
Okay, okay.
So that can be specified. Like as well as a lot of like your institute also, like Mesra campus, and as well as IIT Indore. Then there were the letters, their application letters, appreciation letters, for example, BIT. So there's a Jasser, they got this in 2018. Okay. So Birla Institute of Technology, Sanjay Jasser, as well as IIT Indore also, Dr. Bhupesh Kumar Lad. They are using a witness simulation software, as well as NIT Trichy, Prasanna sir, as well as PSG, so PSG College of Technology. This is a Veroc industry. There a lot of supporting appreciation letters also we have. Then their papers also, if I wanted to show, like IIT Indore, like this, there was some PhD project uh, in the witness. Who was that guy? His name was Sandeep Kumar. Okay, yeah, he's now doing a postdoctorate in IIT Bombay. He was under Larser. Here you can see he was doing a scheduling and sequencing model in the witness. So it's the complexity of that model you can see here. So various types of rules and optimization they wanted to do. They were not able to find a software which can optimize these calculations, and they finally stick to witness. They have used the various type of software like pro model and as well as that arena. They found it very primitive, but when they gone to the witness, now they stick to the witness, and is very much simpler to use and directly do the optimization. And not only that, the various paper they are done shop floor related, they are because they were having some industrial area in that environment. A Simrol, the college is situated in the Simrol area. So there, and he has used a simulated annealing algorithm. So their papers are also there. These are the various journals which are also available. Manufacturing system simulations. If any cement factory, then this is also already shown to you. Traffic controller. Okay, so any other question, any other query, or should we wind up?
Wind up. Thank you so much, Shiv Santosh Patil sir.
Yes, my name is Suraj. There is Shiv Santosh name is there, but my name is Suraj Vaishnav.
Okay, thank you so much, Mr. Suraj.
Yes, thank you, sir. Thank you for your time. Because of that Google Meet, that license version by his email ID, that's why I logged in from his system. If any questions, any doubt, or if you want these case studies, Shivashish will mail you.
Okay,
Okay, he'll be
okay.
in
Okay.
touch with you, sir. Thank you.
Okay.
Thank you, sir. Have a good day. Bye.
Bye.